In order to illustrate the way in which paired t-tests are carried out, we're going to focus on 23 participants. So here are my 23 participants. Remember, in SPSS, each one of these numbers on the side is a participant. And these participants have chronic illness, and we're going to measure two variables. The first one is verbal IQ score, and the second one is performance IQ score. So we have them labeled VIQ for verbal IQ score and PIQ for performance IQ score. So there has been some study that's been done which shows that contrary to healthy people, those with some chronic illnesses have a lower verbal IQ score than their performance IQ score. So we're going to hypothesize here that our participants on these two measures are going to have a significantly lower verbal IQ score than a performance IQ score. We're going to hypothesize that their verbal IQ is lower than their performance IQ. So all participants were measured on both of these variables, verbal IQ and performance IQ. So this is a repeated measures design with two conditions. So for this example, we are predicting that there will be a significant difference in the scores of people with chronic illness on performance IQ and verbal IQ, such that people will score significantly lower on their verbal IQ than their performance IQ. All right, so basically, once you have your variables, once you have your data inputted into SPSS, this basically acts as a calculator for you. So all you're going to do is go up to Analyze, and because we're looking at, we're comparing two different means here. We're comparing the average of these two scores. We want to know if there is a difference between these two things. And remember, we said this is a repeated samples, paired samples t-test. So repeated measures or paired samples t-test right here. We're going to click on that. And we already have these in here, but basically we took our verbal IQ and put it into variable 1. And we took our performance IQ and put it into variable 2. What we're going to do, and by the way, we could go into our options like before, and we could change our confidence interval, but we like 95%. And we're going to leave that. So we're going to hit OK, and we get our results right away. So let's take a look at some of these results. We've got our descriptive statistics first. These are descriptive statistics. The verbal IQ mean, basically that just took all of these numbers, added them together, divided by 23, is 110.52. The performance IQ mean is 112.0. So right away, we can see that by just looking at this, we can see that there is a difference, and it looks like this supports our hypothesis that the verbal IQ is lower than the performance IQ, just by looking at the descriptive statistics. We have 23 in our group. Those are the number of participants in our study. Standard deviations, 12.587 and 9.968 are our standard deviations. And then the standard error of the mean is 2.625 or 2.078. Standard error of the mean. So that's what we could expect by chance, right? Okay, so looking at the next thing here, we have got a correlation here. So remember, in our independent samples t-test, we looked at the Levene's test of variance, of equal variances, because we needed to make sure that both of our groups had a similar within groups variance, so that we were measuring the same thing, so that we could actually compare them to each other. In the paired t-test, our control group and our experimental group are the same, right? There's no difference between them. So we just want to make sure that there's a correlation between those two numbers. If there's no correlation, then we can't really use the paired samples t-test. We paired them because they're similar. Now in this case, there is a correlation here, a moderate correlation of 0.409. Don't worry about that right now. The biggest thing to worry about is the significance. In this case, it's 0.053. So this barely fits into our range of significance, because generally we use 0.05 as an alpha level for significance. So we can say that at 0.053, yes, we can call these close enough to correlated. We can say that there is a significant correlation there between these two numbers. Okay, so that's what that does. If this were 0.1 or 0.2 or something like that, then we definitely wouldn't want to use a paired samples t-test. So here are our results then for the paired sample t-test, and we're going to see that there is a mean difference of -1.478. So that supports our hypothesis. Again, just like we said up here, verbal minus performance, the mean difference is -1.478. So that is supporting our hypothesis. The t-value, going over, because remember when you do a t-test, you're looking for that t-value. The t-value is -0.569, and SPSS does this for you, but basically you could look at a t table and look at the degree of freedom, which is 22. Remember, the number of participants minus 1 is your degree of freedom. And that gives us the significance of 0.575. Now already you should see here that this is not a significant result. 0.575 is pretty big, but remember, this is a two-tailed test. This is a two-tailed test, and we're actually only looking in one direction. We expect that the score was going to be lower. So what I'm going to do is just pull up a calculator here. So I'm not that good with mental math, as you all know. And I'm going to take 0.575, I'm going to divide by 2, and that gives us 0.2875 still, and I could have probably just eyeballed this, but still not a significant result. So in this one, we cannot reject our null hypothesis that there was no difference, and we are going to reject our hypothesis that there was a difference. So basically, we are able to say here that the difference probably is just by sampling error or chance. We might say, although the difference between the groups was in the expected direction, results show that this was not statistically significant. The t-value is 0.569 with a degree of freedom of 22 with a p-value of 0.2875. So there's not enough evidence, therefore, to conclude that the participants differed on their verbal IQ and performance IQ measures.